Okay, hello. This is our first enrichment class on solving algebraic equations. So this group of lessons is purely designed for those people who want to move into more advanced areas of mathematics and feel that when they get to year 10, they will have a better grasp on some of the more advanced algebra that you will need to do. And there will be anyone who's really considering, certainly anyone considering enrichment maths, and certainly anyone who's also probably even going to do standard maths. Okay, so let's start. So what I want to do in this first lesson is look at how we solve linear equations, or how we solve an equation, an algebraic equation. Now, there are many different types of algebraic equations, and the simplest ones are what we call linear equations. And we'll talk about why they're called linear equations later on. Now, to give you an example, a real-life type of example, I suppose, we could set up a little puzzle problem like this. Imagine a number. I'll go to white, I think. Imagine a number, and we have multiplied it by 3, we've taken 7 from it, and I'll try that again. Imagine a number and we've multiplied it by 2, then we've added 3 to it, and the answer is 13. The question is, what was the number we started with? So this is a relatively simple example, but the first step is to write it out as a mathematical equation. So let's just write out the statement first. So we have a number and we're multiplying it by 2. So a number is multiplied by 2 then 3 is added, and the answer is 13. Now, I know what some of you are already thinking. So you might think, I already know the answer for what that number is. That's good. That's fine. That's really good. And that shows that you're already starting to understand and think about how we're going to do this. But I'm going to show you a process that will show you how we get this answer, but the same process can then be used to solve much more complicated equations which you would not be able to do in your head. So it's the process here that's really important. So it's not so much being able to do it in your head before you do the equation. That's not the point. The point is to learn the processes so that you can solve any equation, no matter how difficult, by going through the process. So let's start. So that's almost like a little worded problem. A number is multiplied by 2, then 3 is added, and the answer is 13. And the question is, what is the number? That's the question we want to find. Okay, so the first step would be to write a mathematical equation, an algebraic equation that represents the situation. So let's go ahead and do that. So the number in question, the number, which is what we're trying to find, we will typically call that as some sort of unknown. I'm going to go for x. So I've got a number x. So that's the number we're trying to find. Now it's multiplied by 2. Okay, so that means the number x is multiplied by 2. Remember, 2x means 2 times x. Then 3 is added. So we've multiplied by 2, then we add 3. And the answer is 13. So that equals 13. So there's our mathematical equation that goes with that worded statement. So let's see how we might go ahead and work out what the value of x is. Now, in order to solve these equations, I'm going to use an analogy. Imagine a set of scales. And with this set of scales, if they're in balance, if these scales are in balance, if they're balanced, then that means whatever is sitting in this pan over here must be equivalent, or have the same weight, if you like, as whatever is in this pan over here. So we can use this as an analogy for our equation. And this equal sign tells us whatever we have over here on this side of the equal sign must be equivalent to what is over here. So in other words, all of this must equal this. Now we can move things around. The rules are actually very simple. We can move things around provided we always keep our scales in balance. So let me show you what I mean. Okay, so I might just move that out of the way, I think, a sec. Okay, just move it over there. Right. Now, so 2x plus 3 equals 13. So on this side then, I'm going to write 2x plus 3, that's in balance or equals 13. So imagine 2x plus 3 is on that scale, on that side of the scales, and the 13 is on this side of the scales. They're in balance at the moment. That's what the equal sign means, they're in balance. Now, I want to find out what x is. So what I need to do is try to move everything other than the x off of this pan onto this pan, but every time I do something, I must not let the scales go out of balance. Now, if I wanted to get rid of this positive 3, what I could do is take 3 away from this pan. But if I take 3 away from this pan, the pan's going to tip over. This side's going to be heavier. So if I take 3 from this side, I also have to take 3 from this side to keep my scales balanced. So what I'm going to do, I'm going to take 3 from both sides. So I'm going to minus 3 from both sides. I'm going to take 3 from both sides. So minus 3, but I'm going to minus 3 over here too. So let's work out what we've now got. 3, take away 3, well, they cancel. And so I'm just left with 2x over here, and 13 take away 3 is 10. Now, I know that, remember, everything on this side is in balance with everything on this side, provided whatever I do to this side, I do to that side, do to the other side. So now, 2x equals 10. Okay, so now, in order to find out what my x is, I need to get rid of this number 2. Now, what we need to think of is what is the 2 doing to this side of the equation? And we need to do the opposite to get rid of it. So this 2 is actually multiplying the x. So if I want to remove the 2, I would need to divide it by, if I want to remove the 2 from this side, I'll need to divide by 2. And so if I divided that by 2, like that, that would be great, except, once again, that means I'm halving whatever's on this pan, I've halved it. Well then, clearly, the scale's going to tip over again. So if I'm halving this side, I have to also halve the other side. So here what I did in this side, of course, is we divided both sides by 2. And that's what we've done. So let's now find out what we're left with. Well, the 2 and the 2 cancel, so now we're left with x equals 10 divided by 2, which is 5. So guess what? X equals 5. And that's our answer, and let's just check it. If we substitute x equals 5 into this equation, it should equal 13. Let's see if it does. 5 times 2 is 10, plus 3 is 13. Well, what do you know? It works. So that's a very basic example of solving an algebraic equation. We're going to have a go at another one. So I'm going to clear this board in a sec. So make sure you write down the information there and get ready for the next one. Okay? Okay, so okay, good. Okay, here's our next equation, our next problem. This time, think of a number. Think of a number. We're going to multiply it by 3. So a number is multiplied by 3. Number is multiplied by 3. We subtract 7 from it. 7 is subtracted from it. And the answer is 20. What is the number? Now, what I want you to do is to pause the video. Firstly, I want you to write a mathematical equation for that statement, and then I want you to see if you can, step by step, like we did in the previous example, work out what the value of x is. Once again, I'm sure you all, or what the value of the number is. I'm sure you can already work it out in your head, but what's important here is the process. The process. It's the process that's important. So you must go through that process, all right? So have a go. Pause the video and then play it when you think you've got the answer. Right, well, let's see how you went. So the equation, once again, a number is multiplied, so we don't know what the number is, so I'm going to call it x. Surprise, surprise. So we're going to call that number x, and this time we're multiplying it by 3. So we're going to multiply it by 3. We're subtracting 7 from it, and the answer was 20. Okay, so there was our mathematical statement, or our mathematical equation we wish to now solve. And therefore, going over here, I'm using these lines just to help keep our work organised. So we know that 3x minus 7 is equal to 20. So this is on this scale, and the 20 is on this scale, and the scale should be in balance. So the first thing to do would be to remove the 7, the negative 7. Now, that's minus 7, okay? So it's a minus 7 there. So we need to think, well, what's the opposite of minus 7? It's positive 7. So in order to get rid of that minus 7, I need to plus 7 to this side. So I'm going to plus 7, which is the opposite of minus 7. And then, but I've also got to do it to this side. Remember, I must keep my scales in balance. So here what I've done, I have added 7 to both sides of the equation. And now let's work out what we've got. So 3x minus 7 plus 7, well, they cancel, so we're left with 3x equals 20 plus 7, which is 27. Okay, so the next step here would be to see if we can get rid of the 3. Now the 3, once again, 3x means 3 times x, so the 3 is multiplying the x. So to get rid of that 3, I need to do the opposite of what the 3 is doing, which is to divide by 3. So I'm going to divide that by 3. But if I divide this side by 3, I must also do it to the other side. So here, in this case, we have divided both sides by 3. And when we do that, we can see that the 3's cancel, so we're left with x equals 27 divided by 3, which is 9. And so that's our final answer, x equals 9. Let's just check that it works. So if we substitute x equals 9 into this equation, we should get this answer. So 3 times 9 is 27, minus 7 is 20. That also checks out. So there are our first 2 examples. Now we're going to up the ante a bit, and we'll do two or three more examples which are now increasingly more complex. So make sure you write this down if you haven't already got it, and get ready for example 3. Okay. Now, example 3, I'm just going to write the equation this time. So the equation we wish to solve is 9x minus 4 divided by 5 equals 10. That's a 4, by the way. So there's our equation, 9x minus 4 over 5 equals 10. And the question is, what is the value of x? Another way of thinking about this is like a puzzle problem that we were talking about before. Think of a number. We've multiplied it by 9. We then subtract 4. Then we divide what we've got by 5. And the answer we're left with is 10. What was the number we were thinking of? That's another way of just stating this problem. So if you feel that you can do this on your own, pause the video and give it a shot. Otherwise, just keep watching and we'll see how we go. I will encourage you, whenever you can, whenever you think you can do something on your own, have a go first, because that's how really powerful learning occurs. If you can actively do it rather than passively watching, that's always better. Right, so have a go if you can. Right, let's see how you went. So remember, the equal sign is like the balancing point. So everything on the left-hand side is in this tray, and everything on the right-hand side is in this tray. So over here, we're going to write, it's going to be 9x minus 4 over 5 is on the left-hand side equals 10. Now, the question is here, which number to get rid of first? Well, this is actually 9x minus 4 all divided by 5. So all of that is being divided by 5. So it's probably easiest, as a matter of fact, it's necessary to get rid of the 5 first, because all of this is being divided by 5. So if we get rid of that 5, that will just leave us with what's on the top. So how do we get rid of the 5? Well, let's ask ourselves, what is the 5 doing to all of this? The 5 is dividing, yes, so it's dividing all of this. So what we need to do to get rid of it is to multiply. So you can probably start to see a trick here. Whenever you need to get rid of a number, you do the opposite of what it's actually doing on this side of the equation. So in this particular case, we're going to multiply by 5. But once again, if we do it to this side of the balance or the scales, we must also do it to this side to keep our scales in balance. So we're going to, in this occasion, multiply both sides by the number 5. So let's do that. So 5 out the front, we're timesing that. Now remember, in algebra, we do not need to write a times sign. So 5 bracket all of this means 5 times all of that. That's what that means, okay? And of course, over here, we need to multiply this by 5 as well. Now, clearly I do have to write a times sign here, otherwise you might think it's 510. So it's actually 5 times 10. So let's see what we've got. Well, guess what? Our 5 there will cancel, which is at the top of the fraction, in the numerator, will cancel with the 5 in the denominator. So there's our 5 disappearing. And over here we've got 5 times 10. So over here then we've got 9x minus 4 equals 50. So that's looking a little bit simpler. Now, what do you think is the next number we need to get rid of? Now, if you guessed the negative 4, you're right. So to get rid of that negative 4, well, get rid of the 4 is being subtracted from the 9x. It's being subtracted, so we do the opposite, which is to add. So we're going to add 4 to this side. But yes, that's right, we've got to do it to that side as well. So here we're going to add 4 to both sides of our equation. Okay? So, if we do that, minus 4, positive 4, they cancel. And so we're left with 9x on this side, and that's going to equal 50 plus 4, which is 54. We're nearly there. Okay, so the last step is to now get rid of this 9. So what do you think the 9's doing to the x? That's right, it's multiplying. So what's the opposite of multiplying? Divide, I heard someone say. Well done. Okay, so we're going to divide both sides by 9. So dividing that side by 9, once again, whatever I do to this side, I must do to the other side, otherwise my scales are no longer in balance. So divide that by 9, like that. So, what do we end up with? Well, we've got 9 cancelling with that 9, and 54 divided by 9. Well, if you know your 9 times table, 6 9s are 54, so 54 divided by 9 is 6. So we're left with on this side, x equals 6. And I forgot to write that over here. We are dividing both sides by 9. And there's our answer, x equals 6. Let's see if it works. Do you remember how we check it? Yes, that's right, we actually substitute x equals 6 into the original equation, and if it's the right answer, we should be able to substitute it in and work this out, and the answer should be 10. So let's try that. So we're going to have 9 times 6, so it's 9 times 6 minus 4 over 5. Well, 6 9s are 54. 54 minus 4 is 50, so that's going to equal 50 over 5. 50 over 5 equals 10, and guess what? That's the right-hand side. So yes, we're right. Okay, so copy that down. If there's bits or pieces that you haven't yet copied, and get ready for our final example. Okay. Righto, here's our final example, and this one's going to be a little bit trickier because I'm going to, well, let me just show you what I'm going to do. I'm going to write 3x minus 3 equals 4x minus 7. So in other words, it's like saying, think of a number, we've multiplied it by 3, then we took 3 away from it, and that's the same as if we thought of the same number, multiplied it by 4, and then took away 7. Gee, that's a bit complicated. So the tricky part about this one, to solve it, is you'll notice that the x occurs more than once in our equation. So we need to somehow bring these x terms together to make them just one term, and then we can solve it like we have in the previous examples. Now, one thing that's on our side is that we know that 3x and 4x are like terms. And just to refresh your memory about like terms, if I had, for example, 3x plus 4x, we know that we can add them together, and that would equal 7x. On the other hand, if I had 4x minus 3x, we can subtract them, and that answer would be just x. So because these are like terms, if we can get them together, we can add them or subtract them so they become one single term. And that's the key. So let's start by writing the equation, each side of the equation on the different sides of our scale. So on our left-hand side, we're going to write 3x minus 3. And that equals what's on our right-hand side, which is 4x minus 7. Okay, so what we want to do, we want to get all the x terms, this x term and this x term, together. Now, it doesn't matter whether we get them together on the right-hand side over here or the left-hand side, as long as they're together, and then we can get all the other numbers on the other side. Normally, if you look at the two x terms here, look for the one that's bigger, and that would be the one you would keep where it is. So in this case, because 4x is bigger than 3x, then I would keep the 4x where it was and try to move my 3x. So let's together see if we can work out how to move the 3x. Now, this is positive 3x. It's not negative 3x, it's positive 3x. And we've got positive 3x and 3 is being subtracted from it. So the opposite of positive 3x, or adding 3x to this side of the equation, is to actually remove 3x from this side of the equation. If you imagine that we had on this scale, we had a 3x, a positive 3x, and we had a minus 3 sitting on this scale, then to get rid of that positive 3x, I would have to take it away. I'm physically taking the 3x off the pan. And if I took that 3x off the pan, it's going to be lighter. And so the scales are going to tip that way. But if I took 3x off this side as well, then the scales will be back in balance again. So I'm going to take away 3x from both sides of my equation. I'm going to minus 3x from both sides. So I'm going to minus 3x from this side, and remember, whatever I do to one side, I must do to the other. So I'm going to minus 3x from that side. Okay, so let's see where we're at. So 3x, positive 3x, take away 3x, they cancel. And so over here, we're just left with minus 3. So we've got minus 3 on this side of the equation. Now, 4x minus 3x. So remember, there you go, they're like terms. 4x minus 3x equals x. So over here, we've got x minus 7. And they are still in balance. So let's see what the next step might be. Now look, our x that we're trying to find is over here now, isn't it? Normally on all the other examples, it's been over here, but it's over here now, but that's okay. So we want to get the x on its own. So what's there with the x we need to get rid of? It's the minus 7. So like at the moment, we've got an x sitting on that pan, and we've got a -7 sitting on that pan. So to the opposite of minusing 7 is to plus 7. So if I want to get rid of the -7, I need to add 7. But remember, if I add 7 to this side, I must do it to the other. So this time I'm going to add 7 to this side of the equation, and I have to add 7 to this side as well. It probably helps to use colour coding the way I have, so you can see the actual equation here is in white, and what I'm doing to the equation at each step, I'm doing in a different colour. And at each point, you would notice that this side always equals this side. This side equals this side. And I would like you to follow the same working out process and the same setting out, please. So let's simplify this final one. We've got -3 plus 7. Well, for those of you who are a little bit unsure about your negative and positive numbers, let's just work this one out. So what's -3 plus 7? Well, there's 0. Let's go to -3 on a number line. There it is there. We're starting at -3 and we're jumping 7 spaces to the right. So 1, 2, 3, 4, 5, 6, 7. That's 1, 2, 3. That's where we are, +4. So -3 plus 7 is 4, +4. We don't need to write the positive sign. Equals x minus 7 plus 7, guess what? They cancel. So look at our final answer. X equals 4. So in order to prove this is the right answer, we need to substitute that into our equation to check it. So let's substitute it in. So on the left-hand side, I'm going to write 3 times x, but we're substituting the number 4 in, so it's going to be 3 times 4 minus 3 equals, on the right-hand side, 4 times 4 minus 7. 3 times 4 is 12 minus 3. And over here we've got 4 times 4 is 16 minus 7. 12 minus 3 is 9. 16 minus 7 is 9. And 9 certainly equals 9. That tells us that we are correct. So that's an introduction to solving linear equations. And in the next screencast, we're going to look at solving more complicated more complicated equations. Some of them will be linear and some won't be. We'll also start to learn very soon what a linear equation is and what are the other types of equations we might be dealing with. Okay, thank you.